Hello, welcome to Edexcel demola. Today's lesson we're going to be talking about chemical formula and balancing chemical equations. Maybe a bit of a longer one, but I think it's really important because this is fundamental to literally everything that you're going to do in chemistry. I say that a lot, but literally Module 2 is about building the foundations in chemistry. So we're going to get into it and hopefully you find this video really useful.
Okay, so the first thing that we're going to want to cover is ionic formula. So what this is essentially you're figuring out what the charge of an ion of a specific element is. So we go to our periodic table, right? Now, one thing that we can easily do, group 1, group 2, 3, 5, 6, and 7. We can get the ionic charges quite easily. And we are going to delve more into this when we get into topic 3, but let's just get basics for now. So, group 1, they're going to lose one electron to form a positive 1 ion, as you can see at the bottom of the periodic table there. Group 2, they're going to lose 2 electrons, and then you're going to get a plus 2 charge. Let's move across to group 3, yeah? So you can see the group numbers at the top, by the way. Group 3, they're going to lose 3 electrons to get a plus 3 charge. Group 5, they're going to gain 3 electrons to get a minus 3 charge. Group 6, gain 2 electrons to get a minus 2 charge. And group 7, they're going to gain 1 electron to get a minus charge. So literally, when you talk about the ionic form of any of these elements, we're going to use that charge, and that's what we're going to do. So, like, for example, nitrogen makes N3 minus, oxygen O2 minus, fluorine F minus, magnesium Mg2 plus, aluminium Al3 plus, sodium Na plus. Yeah, I hope that made sense. So those are some examples of them now. Now, compound ions. Unfortunately, we have tried. I feel like we've looked around to find if there is any way that you can like have like a mnemonic or something like this to memorize that. But I'm sorry, it's just gonna have to be just learn them, honestly. I will say they're easier to learn than you think. I think as you keep on doing questions, eventually you're just gonna know that, for example, it's SO4 2 minus, or it's NO3 minus. As you keep doing questions, you're just gonna get used to it. But unfortunately, there's no easy way to learn these. So that's in terms of knowing what is the ionic charge. So now how to get it from the periodic table, and these compound ions are just gonna have to memorize as well. Okay, so there's another important skill that we need to become happy with, and that's finding out the chemical formula. So, for example, we've got sodium bromide, a salt. We're going to need to find out what the chemical formula for that salt is. How do we do that? Now, there's this method that I like to call it the exchange method. Essentially, you're exchanging the charges of your ions, and you're using that to find out how much of each atom is going to be in that salt. So, I'll explain myself more. So, let's look at sodium bromide, for example. We're going to exchange the charge. So this plus is going to go there. This minus, we're going to go across it. It's going to go here. Yeah? So what are they? Their values are with 1. 1 and 1. Right? Hence, NaBr is going to be the chemical formula for sodium bromide. And we'll go through more examples as well. We'll go through more. So that, for example, we've got magnesium chloride here. Magnesium, we're going to take that 2 across, and we're going to take this minus across as well. Right? So you get the 1 here, and you get the 2 here. Hence, MgCl2. Hopefully that makes sense as well. And again, we can get a bit more complex with it. Let's go and look at aluminium sulfide. So the aluminium, we take the 3 here. The sulfide, or the sulfur, the sulfide ion, we're going to take the 2 here, right? So you get a 2 here, a 3 here. And then you're going to get Al2S3. Hope that makes sense. So I'm going to pause for a second. I'm going to let you try some of these compound ions. So we've got sodium nitrate, magnesium hydroxide, and calcium phosphate. Pause the video now if you'd like to. I'm going to quickly run through how to do these as well. So I hope you've paused the video now. And literally, we're just going to work through this quite quickly. Move the 1 here. So you get 1 and 1, so NaNO3. Here, same thing for magnesium hydroxide. We're going to move the 2. I'm going to move this 1, right? So you get 1 and 2. So Mg, and you need to have the hydroxide twice, right? But we're going to have to make use of brackets because we can't separate out that molecule. We can't separate out that part of the compound. So that's how we're going to represent that. And similar thing, harder example, move the 2, move the 3, and then you're going to have 3 here, 2 here. So you get Ca3, again with the brackets, PO4 twice. I hope that makes sense in terms of how we're getting the chemical formula for a lot of these compounds. So these are mostly salts. I hope that made sense. Okay, so we're going to get a bit more technical now, and we need to talk about balancing chemical equations. So, guys, this is going to be really important. And again, it's one of those things that you end up just kind of learning and being used to when you get more practice with it. But you do need to know these type of reactions and know what it forms. So like metal and acid form salt and hydrogen. Acid and base, salt plus water. You need to be able to memorize all of these and be able to pull them out when they ask in the exam, because they won't give you this information. It seems really daunting now at the start of A-level, but I promise you, as soon as you go through, you keep doing your equations, you're going to find this really easy. Cool. Another thing we need to talk about is state symbols. Guys, I can't stress enough, state symbols is something that people just kind of, no one finds it difficult because it's self-explanatory. So like a solid is a solid, a liquid is a liquid, gas is gas. Aqueous just means it's dissolved in water, right? And we can go through typical examples, like your acids and bases are typically aqueous. Metal salts tend to be aqueous as well, unless they are insoluble or they're precipitate. We are going to go more into that in topic 3, in module 3. So don't worry about that too much now. And then your gases, hydrogen, oxygen, carbon dioxide, chlorine gas, they're all just gases, isn't it? So the reason why I'm stressing this so much is because a lot of the time, the question will say include state symbols and people just forget to do it. And you just drop the mark for no reason. You know what I mean? So be very intentional with state symbols. Know what state specific molecules tend to be in, and it will help you out a lot. Cool. Let's go into an example about balancing an equation. So you can see all the workings out here, but I am going to talk through it. So we're reacting magnesium and hydrochloric acid. Now, step 1. We need to know what kind of reaction we're working with, right? So we know that metal is magnesium, and we know hydrochloric acid is an acid. So we go back to our list up here. Metal plus acid goes to metal plus acid plus salt plus hydrogen, right? So we're going to write that out. So we're getting metal plus acid goes to salt plus hydrogen. Now, what else do we need to do? We need to know what salt is formed, right? So we're using magnesium. So magnesium is going to become its ionic state, Mg2 plus. Again, if we chucked it back to the periodic table, magnesium is in group 2. So it loses 2 electrons to form a 2 plus charge. And then chlorine is in group 7. So it's going to gain 1 electron to become -1. Cool. So again, we're going to flip it over. We take the 1 from the chlorine, we take the 2 from the magnesium, and we get our ratio. So it's MgCl2 that we're forming. Now, let's put that in an unbalanced equation. Let's just write it out. Magnesium's our acid, Mg plus the actual acid, HCl, hydrochloric acid, goes to salt, magnesium chloride, MgCl2, plus hydrogen, H2. Happy days. And then also, like you can see here, I'm going to highlight it, we've included our state symbols. So magnesium is a metal, solid. Like we said, acids tend to be aqueous. Salts also tend to be aqueous. And we know that hydrogen is always going to be a gas. Cool. Now, the method that I like to use to solve this out is we split off into your left-hand side the reactants and your right-hand side the products. So let's look how much we got of each. So in black, you can see what we've got initially. We've got 1 magnesium on the left. We've got 1 hydrogen. We've got 1 chlorine. On the right, we've got 1 magnesium, 2 hydrogen, 2 chlorine. Now, I would always say start with anything that's not hydrogen. If you start with hydrogen, you're kind of playing yourself. So we're going to start with balancing out the chlorine because there's a difference between left and right. So I see, if we multiply the chlorines by 2, then we're in business, right? We multiply the chlorine by 2 by adding a 2 here. So I'll actually do it in purple. If we add a 2, oh, that's not the right purple, guys. Right here. If we put a 2 there, we can see that now the chlorine's 2 on the left, but then also the hydrogen is going to be 2. So both of them get times by 2. And then actually, very fortunately for us, that's our equation balanced. So you can see that is your full balanced equation. Hope that made sense. We're going to go into another example just so that we can really drill this point home. Okay, so we're going to go into a bit more of a more difficult example, but hopefully this should show you the process. So, aluminium hydroxide plus nitric acid. Now, if we went back to our table, we would see metal hydroxide plus acid goes to salt plus water. So, pardon me. We know exactly what we want to form. Now, what salt is being formed? I can see here, we got aluminium and nitric ion, yeah? So, you have got to remember what those ions are. Aluminium is in group 3. Group 3 forms 3 plus ions because they're going to lose 3 electrons. So you're going to say Al 3 plus, right? And then you've also got nitric acid. What nitrate ion is going to be NO3 minus. Cool. Again, let's flip the charges. Cool. So we're going to move the 3 to this side. We're going to move the 1 to that side. 1 here, 3 here, which means that we got Al, and then you've got to use the brackets because we've got to keep that nitrate ion together. NO3 thrice. Yeah? So we know what salt we're forming. Now we can make an equation. Cool. And we put our state symbols there as well. So you got the equation AlOH3. Remember, we can also write this here because we would need to know what the initial one was, right? So OH minus Al3 plus. We would again pretty much do the same thing when we swap the charges. 1, 3 here. And you get AlOH 3 times. Cool. Now, that's our equation. Hydroxides, again, we're going to cover it in module 3. This one would be solid, yeah? And then you've got your nitric acid, which is aqueous salt, and then, sorry, I've forgotten to rub that out. Aqueous salt, and you've got water, which is always going to be liquid. Unless they've told you it's like steam or something. Cool. Let's see how much we've got on each side. So, by our calculations, we look to the left. There's 1 aluminium. And now, guys, this is the tricky part. Brackets always get people. Be really, really careful when you're working with the brackets. So, we've actually got 3 oxygens from the aluminium hydroxide. And we've got another 3 from the nitric acid. So, we've got 6 in total. Hydrogen as well. We've got 3 from the aluminium hydroxide, because the times in the bracket are 3. And we've got 1 in the nitric acid, so 4 total. And we've got 1 nitrogen. Happy with that? Cool. Now, on the right-hand side, again, brackets always gets people, guys. We've got 1 aluminium. Look here. We're times in the bracket by 3. So we know we've got 3 nitrogen. Happy. How many oxygen do we have? 3 times 3, 9. We can't forget about water. So you've got 10 oxygen total. And then with water, with the hydrogen, it's in water, so you just got 2. Now, easiest way to approach this question is, I want to balance the nitrogen first. Because aluminium is already balanced. Typically, you don't start with oxygen or hydrogen because it will just get really confusing. So start with the nitrogen. Now, we're going to times it by 3 because that's how we can get it to 3. Yeah. So we put a 3 here. Let's see how that changes things up. Right. Now, all of a sudden, we've got 3 nitrogen. How many hydrogen do we have? We already had the 3 from here. We've added in another 3. Yeah. You can see that because we're timesing the whole nitric acid by 3. So now we've got 6. We've got 6 hydrogen. Cool. How much oxygen do we have? Well, we already had the 3 from aluminium hydroxide. Now, the nitric acid, we've got 3 multiplied by the 3. So, total, we've got 12. Cool. Now, we can tell this still isn't balanced. We still need to do more so that we can actually balance this equation. So, what do I want to look at? I think now I'd have a look at hydrogen. I would have a look at hydrogen now. So, it's an easy fix. What can we do? We've got 2 hydrogen here. I'm just going to times it by 3 to get me to 6. Yeah. So we'll put this 3. And then what's that going to change with the oxygen? Well, we look at the aluminium nitrate. We already had 3 times 3, 9. Cool. When you add on the water now, because you've got 3 water molecules, it's going to be 9 plus 3, 12. And you can see that we're balanced. Easy. We're balanced. We can make this a bit more clearer, but we are balanced. So now, we've done the workings out. We can just finalize our equation, right? So put a 3 here and a 3 here. And our equation is solved. I hope that made sense as a work through for how to solve this question. Okay, well, it's always good to put yourself to the test. So we've got 3 questions here. Now, first one, you're just writing out chemical formula for like different ions or different salts. Second one, I want you to actually work out what these equations are. I want you to work out the balancing. Now, I have included the compounds being formed for you just because you are quite early in your A-level chemistry, so I don't want to overwhelm you. So I've included what's being formed, but you are going to have to work out, is it solid, is this aqueous, is it liquid, is it gas, right? So we're going to give you some time to do that, and we'll get into the answers afterwards. We're getting into our answers now. So, in terms of knowing your chemical formulae for your ions, some of these are just going to be really cool. So like the first few will just be equal. Zinc You'll learn more about transition elements in module 5, I believe. Maybe module 3 as well. But worry about that a bit more later. Other ones you would have had to work out just using the method we did before. So just bring across the charges, and that will help you to figure out how much of each atom or how much of each element you're going to need. Cool. The equations were a bit more difficult, so I've done the workings out here. We are literally following the same method we did before. So I won't explain it, but you can see the thought process, I would hope, if you're here. Again, any questions, just drop them in the comments. But that would be for question 3. And for question 4, we're going to have this. So question 4 was a 2-step one. But you should have been able to get these answers based off what we've gone through in this lesson. And the state symbols I've added in. I normally do state symbols first. I would normally do state symbols first just to make sure that you don't forget it, literally. So those are the answers for your questions. Okay, so we're coming towards the end of the lesson, and you know what that means? It is A-star tip time. What would I definitely do for this topic? I would, look, the left-hand side, right-hand side thing is a bit long, especially if you think, oh, look, I've just seen that, I know what the answer is. But honestly, I'd say use it. You don't want to think that you know it, make a silly mistake, and then drop easy marks in the exam. Definitely use the tables. Start with balancing the compound ions and metals. So, like, for example, if you see a nitrogen in there, start by balancing that. You do not want to start with hydrogen or oxygen. You will end up confusing yourself. State symbols, so easy to forget. And I've really tried to hammer this in this lesson. It is so easy to forget state symbols, and they are an easy mark to just add on to these questions. So make sure to remember them. Different types of reactions and the compound ions. I would say as you continue in chemistry, you're going to just be able to recognize that, like, salt plus base plus acid is going to be salt plus water. Like, you will get more used to it. It might seem a bit daunting now, but it will be fine by the end of the course. So I'd just say make sure you're doing these questions or exposing yourself to them, and you will find it a bit more familiar. What would I not do? Now, I'll put it in there again. State symbols, please, 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 please do not forget state symbols. It's a really, really easy mark to pick up. Again, don't balance hydrogen or oxygen first. Don't confuse your coefficients with the subscripts, and also just be aware of them whilst you're balancing the equations. You don't want to forget that was a subscript there, and then you're losing out on more marks because it's not going to be balanced properly. So be aware of that. And then also ide, ites, and ates. Now, these suffixes annoy me, but you do need to be aware of them. So, like, we could put an example. We'll just do a short example here. So we can have sulfide, we can have sulfites, and we can have sulfate. And those happen to be your ions on the end. So ide just means it's the element alone. Ite means it has fewer oxygen. Ate means it has more. So you can see that, like, sulfate, SO4 2 minus, sulfite, SO3 2 minus, sulfide, S2 minus, right? Just be aware of that as well. Now, that is the end of the lesson. So thank you so much for tuning in today. Hope it was really helpful. Any questions, let me know in the comments. I'm going to do my best to answer. Drop a like, subscribe, and I will see you in the next one. Bye for now.